All right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD 1000 Web Development Technologies course, I've been creating a series of video presentations that are based on the Mozilla Developer Network Learn Web Development series. We're into server-side website programming, and this is our client-side or client-server overview. Let me just tell you that how this has kind of changed over time. All right. In fact, let's see if I can find that picture. Let's see. Free downloads. I don't want chapter 5. What do I get from this one? Well, let me just tell you what I wanted to show you. Let's see if they show something here. Let's go out to images, Google Images here. And we'll put in client server. All right. Yeah, this will work. Okay. All right. It used to be when you showed a picture like this, the clients were basically all desktop computers. Well, then with the advent of laptops, and then with the advent of phones, mobile phones and tablets, that's how this has changed. All right, the client is you. And in a client server network, it's you making requests over the internet, these HTTP requests, and those requests going to a server someplace. That server may be able to, again, if it's as we've already mentioned, if it's a static type of site, the server may be able to give you back pre-done HTML, CSS, and JavaScript. Otherwise, if it's got to grab information from a database or whatever, it may have to contact other servers. But this kind of, in a nutshell, is what we're talking about with the client-server model. So the author says here, now that you know the purpose and potential benefits of server-side programming, we're going to examine what happens in detail when the server receives a dynamic request from a browser. Most server-side code handles requests and responses in similar ways. They use different languages. All right, 3 of the most popular, again, are Node.js, which isn't really a language as much as it's the use of JavaScript on the server side. All right, Django, which again isn't a language, it's the Node.js equivalent that's used whereas Node.js is used with JavaScript, Django is used with Python. PHP is a language that's used, all right, and it is a server-side language. All right. There's no real code discussion here because we haven't yet chosen a web framework to use to write our code. All right, so in other words, it's going to be done in a very generic way. But as mentioned there, the discussion is still relevant, however, because the described behavior must be implemented by the server's side code regardless of the programming language or web framework that you choose. All right, so we've already mentioned this, that web browsers communicate with web servers using HTTP. When you click on a link, submit a form, run a search, etc., all right, as it says, the browser sends an HTTP request to the server. Now that request, as mentioned here, and I'm not going to read every bit of this in here, but it includes a lot of things. Much of this information that it includes is, for lack of better words, almost buried in what are referred to as headers. All right, so you don't see that information that gets sent out. All right, I just sit there and type in Amazon.com and hit enter. All right, but what gets received on the other end is other information. So as it says, the request includes, amongst other things, a URL and identifying the target server and resource, the method that's being used, and there are several of these methods here. All right, we've only talked so far about get to acquire or access a certain resource, and post to create a new resource, but there's other ones. All right. And eventually you end up, especially when you get into talking databases and about talking about something known as CRUD, which means create, which is more or less like a post, read, which is more or less like a get, update, which is more or less like a put, and delete. All right, and there may be additional information in there. For instance, if I go out and I come in here, and this was the URL that I put in, so I went to Google Images, and I put in a search for client server. And notice it pushed me off to Google, and it says I'm searching for what? It says client space server. The point is the information that it's giving me after this, the question mark and beyond, this is known as a query string. So it's information that the server needs in order to be able to give me the information that I'm desiring. So you'll notice if I come in here and remove all that stuff, now I'm just back at Google. All right? And you saw what happened when I went in there. But if I go in there again into images.google.com, and now I search for something else. So let's say I search here for node.js and I hit enter, this changes. So rather than saying client server, it's node.js. All right, so it is tailoring what I am asking for based on, or what it's returning based on what I'm asking for. All right. Web servers, as it says, wait for client request messages. They process them as they arrive, and they reply to them, all right, in one form or another. It says typically if they can do it okay, they'll give you something like a 200, which means everything was okay. I already showed you, and it wasn't a 404, but basically that's what happened when I put in Rankin.edu instead of Rankin, because it couldn't be found. Another example here is a 403. All right, so if I were to go in and request something that I didn't have access to, I'd get that kind of a message. All right, when an HTML page is returned, it is rendered by the web browser. As part of the processing, the browser may discover links to other resources and will send separate HTTP requests to download these files. Both static and dynamic websites use exactly the same communication protocol and patterns. So, it says you can make a simple GET request by clicking on a link or searching on a site. For example, the HTTP request that is sent when you perform a search on the Mozilla Developer Network for the term client server overview, as it says, will look a lot like the text shown below. So that's all the stuff that gets sent. So each line of the request, as it mentions, contains information about it. The first part is known as the header, and it contains information the same way that the HTML head contains information about the document, but not the content itself. Now they explain what's going on in here, the type of request, the target URL. So there's the type, there's the target URL. All right, here's the parameters. It says the target host website. And it says the end of the first line also includes a short string identifying the protocol version that's being used. All right. The final line contains information about client-side cookies. And we've talked a little bit about cookies before. All right. And again, cookies are information that gets sent from the server to the browser. They typically get written to the browser. They're text files. They're small files. Typically, they have a size of 4K or less. And typically you have a certain limited number of cookies that your browser will accept. All right. So the first part of the response to this, as it says, is shown below. The header again contains information. In this case, it says it worked. It also says, what it's returning. So somewhere in here, it's returning formatted text. It says you can see we're also using the UTF-8 character set, which means we're using Unicode. It also tells us how big it is. At the end of the message, it says, then we see the actual body content, which contains the actual HTML returned by the request. The remainder of the response header includes information about the response, the server, and how it expects the browser to handle the page. Now, that was a GET. Remember, a GET is designed to provide you information, but for lack of better words, it's kind of like a read-only type of thing, because you are requesting information. Typically with a post, you're submitting information. So most often this is equated, for example, with you sending something, where you fill out a form online. So again, they show you the text when the user submits new profile details. And you'll notice that much of the stuff, other than previously that was GET, again, it's going to give us where, the URL, the host, etc. So it says the main difference is the URL doesn't have parameters. The information from the form is encoded inside of the body of the request. That's really important because what they could be asking you for there would be sensitive information, credit card information, password information, etc. So whereas the information for a GET is shown in the query string up here, the information for a post is not. It's hidden inside of the header. That doesn't mean you can't find it, but it's harder for you to find. And quite often, especially sensitive information, you're going to find is encrypted. All right? Because you don't want it where people can dig in, go out to the internet and find out things like people's, credit card numbers, etc. All right, so the response from that is shown below. It says the status code of 302 found tells the browser the post succeeded, and it must issue a second HTTP request to load the page specified at the location. Now, we've talked a little bit about static sites versus dynamic sites. Okay, so we've looked at these already. Again, a static site returns basically the same thing every time. So let's suppose I go out to rankin.edu. All right, the chances are pretty darn good if I go out there tomorrow, it's going to look the same. But let's suppose that today, Rankin decided that they were going to have a new program. All right. Typically, with a static site, what you'd have to do then would be to take the site down, add the new information, and bring the site back up. All right. But if you've got a dynamic site, you should just be able to add it. There is dynamicity. I would consider this to be a static site. Notice, we're online. How may I help you today? All right. Static sites are excellent when you have a small number of pages and you want to send the same content to every user. That's what we will be doing with the copies of the You Can Call Me Mo site that we're going to create. So they talk again about how this works. It says when a user wants to navigate to a page, the browser sends an HTTP request, GET request, specifying the URL of its HTML page. The server retrieves the requested document and returns the response, along with a status code. 200 if it was okay, 404 if it was not found, 403 if it was forbidden, etc. The server on the static site will only ever need to process GET requests because it doesn't store modifiable data. On the other hand, when you work with a dynamic site, as it says, it is one that can generate and return content based on the specific request URL, rather than the same data every time. You've already seen this kind of thing as I've requested different products, for example, from Amazon. Quite often these make use of a database to allow product information to be stored efficiently and in an extensible, modifiable, and searchable type of manner. As they mention here, using HTML requests and templates rather makes it easy to change what you're looking for. So, as it says, the diagram below shows the main elements of a different website. Okay? And it says after you submit a form, all right, the sequence of operations is this. The browser creates the GET request to the server using the base URL. The web server detects that the request is dynamic, so it has to forward it on, typically to a different server, to figure out how to handle it. The web application identifies the intention of this request is to get the best team list based on a URL, so the web app is going to dynamically generate the HTML page. All right, it'll return the generated HTML to the browser. All right, which will then start to process the returned HTML, etc. Now, as it says there, the web application's job is to retrieve HTTP requests and return HTTP responses. While interacting with a database to get or update information are common tasks, the code may do other things at the same time or not interact with a database at all. We've already talked about this. All right, just going out to Amazon is not the same thing as going out to Amazon and searching for something, as an example. Now, server-side website code, as it mentions there, does not have to return HTML. It can return PDFs. You might go out to a site and ask for something that's not HTML. The idea of returning data to a web browser so that it can dynamically update its own content, all right, has been around for a while. More recently, single-page apps have become popular when the whole site is written with a single HTML file that is dynamically updated as needed. Websites created using this style push a lot of the information from the server to the browser and can result in websites that basically look a lot more like native type of apps. They're very responsive. All right. Web frameworks simplify server-side web programming. It's one of the reasons they're popular. So as it says there, one of the most important operations they perform is providing a simple mechanisms to map URLs for different resource pages to specific handler functions. It also makes it easy to view functions to fetch information from a database. And again, they have some examples. We're going to be going through some stuff in just a bit. All right. So at this point, it says you should have a good overview of the operations that server-side code has to perform. Next should be our server-side frameworks. And if I come back up here, again, we've done this and this and this. So yeah, we're up to server-side web frameworks, which I'll cover momentarily.